Welcome back to TypeSpec 101. I'm Mario Guerra, the TypeSpec product manager at Microsoft. In this video, we're covering a topic that every developer knows all too well: handling errors. Let's face it, things don't always go as planned. Sometimes servers crash, requests are malformed, or someone's just trying to do something they aren't allowed to do because why not? So you've got to handle errors, and it helps to have a consistent way to specify those error responses. We're going to explore how to define error models and show how to add them as possible responses to your CRUD operations in TypeSpec. If you'd like to follow along with the tutorial sessions, you can download the session files from aka.ms/typespec101/files. This will give you access to the end result of changes made to main TSP for each video. You can easily cut and paste from these files to follow along and implement the changes as we go through the tutorials. Before we start coding, let's talk about why using error models is a good idea. But first, what exactly is an error model anyway? In TypeSpec, a model is a structured way to represent information. So, an error model is simply a structured way to represent error information. Imagine a user is interacting with your service API and something goes wrong. Instead of just returning a generic and vague status code, you can return a detailed message that explains what went wrong. This way, if your user has done something wrong on their end, they can potentially do something to fix it. Error models also help you bring consistency to your API. Instead of returning different error message formats from various endpoints for the same type of error, you can ensure a consistent response format every time. This makes it easier for clients to handle errors in a consistent way. They also just save you time writing code. I'm a big fan of code reuse, and error models are a great way to implement a write once, use everywhere strategy. Plus, if you're using VS Code with GitHub Copilot, you'll appreciate how it auto-completes the responses for you as you develop your API. Let's define error models for some common errors. I want to stress that these are just examples, and you can define error models that make sense for your specific API. They're not meant to be comprehensive, but they should give you a good starting point. I'll define 3 models to represent validation errors, not found errors, and internal server errors. Here's how you could do that in TypeSpec. I've introduced the error decorator here, and as the name implies, this decorator is used to indicate that a model represents an error response. No surprises there. The not found error model includes a code and a message. The validation error model also includes a code and a message, plus an array of details. Finally, the internal server error model has a code and a message as well. While the backend service will populate these details, defining these models upfront ensures we provide structured and consistent error responses across our API. Now I'm going to modify our pets namespace CRUD operations to include these error models as possible responses. Okay, we've added the error models as possible responses for some of our CRUD operations. For example, the getPet operation can now return a not found error, if the pet is not found. The createPet operation can return a validation error if the request is invalid, and the updatePet operation can return an internal server error if something goes wrong on the server. Even though I'm only demonstrating this with a single resource route, i.e. /pets, if I had other resource routes defined within the pet store namespace, these same error models could be applied across all the routes. This consistency is great for clients that need to handle errors, since they can rely on a uniform error response format throughout the entire API. Let's take a look at how these error models show up in the OpenAPI spec. We'll look at the responses for the updatePet operation. As you can see, the error responses for the updatePet operation are listed in the responses section, each referencing the corresponding error model schema defined in the component section of the spec. And that's it for specifying error responses in your REST API using TypeSpec. We've covered why error models are beneficial, how to define them, and how to use them in your API operations. In the next video, we'll discuss reusing common parameters in your REST API.